As I mentioned in our last lesson, we've got a bit of a stretch of, I don't know, I guess I would say they're easier lessons. I hope you guys feel that way too. Only because we've already spent a lot of time in approaching equations and solving them the right way using inverse operations. And I think that really begins with understanding what an equation is. An equation is our balanced scale. Here we have A equals B, and so we're learning about the multiplicative property of equality. Yesterday we learned about the addition property of equality. Very, very similar. Yesterday with the addition property of equality we said if A equals B we can add C to both sides and we still have an equation. It's still equal. Today we're learning the multiplicative property, which is going to say if A equals B, if we multiply both sides by the same thing, we still have an equation. And we apply that to solving equations because it's going to help us to isolate the variable. Here we've got 5x equals 20. And our goal is to get x by itself on one side of the equation. We don't have x by itself. We say, what are we doing to poor little x? We are multiplying x by 5. How do we undo that? We divide by 5. And right away you're going to say, or you might say, wait a minute, if we're going to divide by 5, I thought we were going to use the multiplicative, hard to say, property of equation. So why are we dividing if we're supposed to be multiplying? Well, the truth is really we're never going to divide again. We're always going to multiply by a reciprocal. For example, if I took the number 20 and said I was going to divide it by 2, I would get 10. But instead of dividing by 2, I'm going to multiply it by the reciprocal of 2. So we're never going to divide anymore by a number. We're always going to multiply by the reciprocal. So really I'm going to multiply by its reciprocal, which is 1 over 2. So 1/2 times 20, you'll see, is the same thing as 20 divided by 2, which, you've had enough experience with those types of problems that you knew that. But just a reminder that multiplying by the reciprocal is the exact same thing as dividing. So really, when we divide by 5, and I'm still going to use the phrase divide by 5 when we cover these things. It's going to be more important when we get to the next example with fractions that we would say, might say multiply by the reciprocal because we're dealing with fractions. But I think it's okay to say divide by 5, and we know that in a way we're still multiplying. We're multiplying by 1/5. Dividing by 5, dividing 20 by 5 on this other side here is the exact same thing as multiplying it by 1/5. We're going to get the same answer. So 5 over 5 does not equal 0. It equals 1. Common mistake. 1 times x is x. And what we did to one side, we did to the other here. X equals 4. We knew that to be true just from looking at the original equation. One more example. 2/5 equals 7. Our goal is to get x by itself. Do we have x by itself? No. What are we doing to poor little x? Multiplying them by 2/5. How do we undo that? We divide by 2/5. Here's where it might make a little more sense to say, well, we don't divide fractions. We multiply by their reciprocals. So times 5/2, what we do to one side, we do to the other. These all reduce to 1. It isn't like they really go away. They just reduce to 1. And 1 times x equals x. And over here we've got 35 over 2. Or we could put it into an improper or a mixed number and write it as 17.5. Again, this is the multiplicative property of equality. So now we've learned that we can add and subtract from both sides of an equation. As long as we do the same thing, we've still got an equation. And now we can multiply and divide, things we've been doing all along throughout the year anyway.